The PCB Editor SKILL API provides the axlDBCreateExternalDRC function to allow you to programmatically add DRC markers to the PCB Editor database. In a previous training byte, we wrote an example function that reported any connect lines that had a length that was less than half the width of the line. Let's revisit this example, and have it add a DRC marker on one of the endpoints of any of the short segments. At this point in the function, we have found the short segment. So we will add the axlDBCreateExternalDRC function to have the markers added. The axlDBCreateExternalDRC function has 2 required arguments, and 4 optional arguments. The first argument is a string with the name of the violated constraint. We'll call our constraint, wicked short segment. The second argument is the location of the DRC marker. We'll use the first endpoint of the short segment as the location for our DRC marker. The third argument is the layer that the DRC marker will be added to. It is always added on the class DRC error class, so we can just include the subclass in this string. We will add our markers on the layer that the violating connect line segment is on. So we'll use the --layer operator on our segment DBID to get the layer which will be in the format class/subclass. We only want the subclass from that layer, so we'll use the parseString function on the layer, with a delimiter of the /character. So this will break the layer down into a list of 2 items. The first item will be the class, and the second will be the subclass. So we'll use the nth function to just grab the subclass, and we'll use this as the third argument to the axlDBCreateExternalDRC function. The fourth argument is a list of either 1 or 2 DBIDs. In general, you'll supply the DBID of the element, or elements, that are responsible for the error, so we'll include the DBID of the short segment. This element will be automatically highlighted when we use the showElement command on our DRC marker. The fifth argument is a second reference point. This is a coordinate on the object of a DRC pair that does not have the DRC marker on it. Using this point, you can identify the second object involved in causing the DRC by reading the DRC data in later processes. Since our marker is caused by a single element, we will use nil for this argument. The final argument is the actual value of the object, and this will also show up in the showElement window. We'll use the length of the segment divided by the width of the segment for our actual value. So we should get a DRC marker anytime this value is less than 0.5. This does need to be a string, so we'll use the sprintf function to have our floating point number returned as a string. Let's load and run our program, and we notice that one short segment was reported, but we don't see our DRC marker. If we turn on the DRC error class, we see that our DRC marker really was added, and it's on the same subclass as the short segment. If we use the showElement command on the DRC marker, we see the constraint set name that was violated, the location of our DRC marker, and the subclass of the marker as well. When we hover over the DRC marker, the segment in violation is highlighted, and our actual value is included in the showElement window also. The DRC marker is associated with that small segment, and if we use the vertex command to remove the segment, then the DRC marker is removed as well. However, notice that if we move the offending segment, the DRC marker does not move with the segment. This can cause your DRC markers to get out of sync with the offending segments. If we run our function again, our segment is found, reported, and marked, but the original DRC marker did not go away. I usually put a loop in this type of function to delete any existing DRC markers that were created by our function. There are several ways to do this, but the easiest is to just loop through all the DRC markers in the database, which we can get from the --DRC's operator, on the database DBID. Each DRC DBID will have an attribute called source, and the --source operator will return the constraint set name of the DRC. When we find a DRC marker whose source is wicked short segment, we will use the axlDeleteObject function on the DRC marker DBID to delete the DRC. Now when we load and run our function, any wicked short segment DRCs are first removed, and then new ones are added for any short segments in the area that we select. In summary, updating our function to add DRC markers to the editor database was made nearly trivial by using the axlDBCreateExternalDRC function.